Hello and welcome to Not More Maths for Dummies. Mathematics is something that many people struggle with, and the way it's set out often doesn't help with this. On Wikipedia, for example, it's very common to see large blocks of symbols and equations without very much English at all. You may find the same thing in some mathematics textbooks, although some are better than others. It's often difficult to find places where it's easy to learn mathematics, and so that's what I will attempt to create in this video series. In what is probably a very bad move indeed, I won't be presenting these in any particular order, and some of these videos will be more advanced than others. If this is too easy or too difficult for you, then please say so and I'll cover something else in my next video. So, in this video, I intend to explain what this symbol does. You may have seen it before. It looks a bit like a spiky E or an M tipped on its side. It appears in Microsoft Excel for the auto sum function, so it should come as no surprise that it's used in mathematics to represent sums, and it's a convenient way to write long sums out in a short space. Here's a typical example of what I mean. It looks complicated, but really, all it means is the sum of all integers n, where n ranges from 4 to 12. That is, 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11 plus 12. This is quite a mouthful, so you can see what I mean by it saving quite a lot of space, or ink or paper or whatever you want in whatever format you're presenting this. You don't have to use n if we don't want to. We could use K, or R, or P, or Z, or a picture of Michael Schumacher. It really doesn't make any difference. However, a common choice for this is the letter I, and so that's what I'll be using in this video. What about this example? Here we have I squared instead of just I. It's very much the same idea as the first example though, but here we're squaring all the numbers that we're adding and going from 3 to 7. That is 3 squared plus 4 squared plus 5 squared plus 6 squared plus 7 squared, which then simplifies to 9 plus 16 plus 25 plus 36 plus 49. And if we put that into a calculator, we would then find it was 135. Since we only had 5 terms to add up here, we could quite easily have just used a calculator. However, what if we had more than that? This sum here is the sum of the integers from 1 to 50. If we tried to stick that into a calculator, then it would involve a lot of boring typing. If you want something more interesting to do, I'd recommend watching the European Grand Prix at Valencia. Fortunately, as I shall now demonstrate, there is an easier way to do it which doesn't require you to key 50 numbers into a calculator. Remember that this thing is the sum of all the integers from 1 to 50. That is, 1 plus 2 plus 3 and so on up to 50. I won't say it out in full because I'll run out of breath, and I won't write it out in full because I'll run out of space. However, it doesn't matter what order we add the numbers in. We could just as easily add them in reverse order if we wanted to, and we'd still get the same thing in the end. Now I'm going to add the top line, that is the sum forwards, to the bottom line, that is the sum reversed, and we'll see what happens. Starting with the left hand side, if we add the sum to itself, we just get 2 lots of it. Now, moving over to the right hand side, 1 plus 50 is 51, 2 plus 49 is 51, 3 plus 48 is 51, and so on until we get to 50 plus 1, which is also 51. Basically, we've ended up with 50 lots of 51 here. Now, if we divide both of the sides of the equation by 2, the 2's on the left-hand side cancel out, so we just end up with the sum of the first 50 integers, which is of course what we're looking for. But on the right-hand side, we have something nice that we can just stick into a calculator without doing lots of boring keying in. The other thing is, this trick doesn't just work for the first 50 integers. We could do it for 100, or 200, or 500, or 2010, or 65,537 if we wanted, and thank goodness, we wouldn't have to key in 65,537 numbers. In fact, we could do this for whatever positive integer we want. and so we obtain this formula. The sum of the first n integers is equal to n multiplied by n plus 1 divided by 2. These sums also have two nice properties. The first one concerns what to do if the expression you're trying to sum is itself the sum of two or more different expressions. Take this example. We're summing I plus 2, with I ranging from 1 to 25. Well, here we're allowed to split it into two sums, calculate them individually, and then add them together at the end. The jargon for this is sigma distributes across addition. It also happens that it distributes across subtraction, but not across multiplication or division, so don't try to do this to simplify products of two or more expressions. Now, the first of these two sums here is the sum of the first 25 integers, which we have a formula for. This is 25 multiplied by 25 plus 1 divided by 2, if you remember from the last example. In the second sum, we're just adding 2 to itself 25 times, so we just end up with 25 copies of 2. Now we can stick the first of these into a calculator and we get 325. The second one is simple enough to do without a calculator, the answer's 50. Now we just add these and we get 375. The second nice property concerns what to do if we're multiplying by a fixed number. In this example, each term is multiplied by 8. Here, we're allowed to move the 8 outside and multiply by it at the end. Now what we're left with is just the sum of the first 17 integers, so we stick 17 into the formula that we have, and now we have something that we can put into a calculator. When we do, we get 153. Finally, when we multiply this by the 8 that we removed at the beginning, we get 1224. That's it for this video. Please tell me how you found it, and whether there's anything that needs explaining further. I haven't yet decided what the second video will be on, but if anyone has any specific requests, then please let me know. Until next time though, that's it. Have a nice day.